Yet another method of creating streamlined holding circuits exists for the TECO SG2 PLR. This method makes use of set and reset coils, which differ from traditional output enable instructions in that a single output can be placed in one of two mutually exclusive states, either set or reset, and once in that particular state, the PLC will maintain this condition until such time that the opposite state is asserted. Set, if you want to think of it this way, can be thought of as a command that, when asserted, energizes an output and keeps it energized. Similarly, reset can be thought of as a command that, when asserted, de-energizes an output and keeps it de-energized. The states set and reset are to be considered mutually exclusive in that both states cannot be simultaneously achieved. It is assumed that the reset state has priority, and if faulty logic or some odd condition simultaneously tries to assert both states, the output will remain de-energized until such time that the conflict is resolved. Additionally, good practices preclude the use of multiple set conditions within the same program, which may yield undesirable behavior. To make use of a set coil in the TECO SG2 client programming software, one must select set when placing an output in a program. Here, rung 1 contains a make instruction examining input I3, the normally open green push button, in series with the set function for output Q1. The TECO SG2 client programming software symbolizes a set using an upwards pointing arrow. Not all manufacturers use this particular shorthand notation. Next, we'll insert a break instruction examining input I2, the normally closed red push button on rung 2. One must select break when placing this instruction in the program. Note the TECO SG2 client programming software symbolizes a break function using lowercase letters. Not all manufacturers use this particular shorthand notation. Similarly, to make use of a reset coil in the TECO SG2 client programming software, one must select reset when placing an output in the program. The completed rung 2 contains a break instruction examining input I2, the normally closed red push button, in series with a reset function for output Q1. The TECO SG2 client programming software symbolizes a set using a downwards pointing arrow. Not all manufacturers use this particular shorthand notation. You note that the break instruction in this scenario is necessary since the electromechanical nature of the field input device attached to input I2 is normally closed. You recall that the break instruction is essentially the opposite of the make instruction, and that a break instruction disallows logical continuity when input I2 experiences a logical 1, the deactivated normally closed state of the red push button, and allows logical continuity when input I2 experiences a logical 0, the activated held open state of the red push button. The break instruction allows the reset condition to be asserted only when an operator actively holds the normally closed red push button open. In contrast, the logic in rung 1 using the make instruction examining input I3 allows the set condition to be asserted only when an operator holds the normally open green push button closed. One can see how, using this alternative set-reset approach, the program is ever so slightly easier to understand. The logic in rung 1 energizes the output and keeps it energized. The logic in rung 2 de-energizes the output and keeps it de-energized. Using the TECO SG2 client programming software simulator utility, let's examine the behavior of this program in response to simulated field input devices in various actuation states. Note the TECO SG2 client programming software simulator utility default start state assumes the electromechanical nature of all switched input is normally open. Before initiating the simulation, one must toggle the simulated field input device attached to input 2 to closed to more accurately reflect our as-built system. In the deactivated ready state, note the simulator initiates operation with output Q1 de-energized. The make instruction examining input I3 does not permit logical continuity to the set instruction of Q1. Additionally, the break instruction examining input I2 does not permit logical continuity to the reset instruction of Q1. Since output Q1 is neither being set nor reset, output Q1 remains in the de-energized condition. When the simulated field input device on input 3 is closed, the make instruction examining input I3 permits logical continuity onto the set instruction of Q1. Output Q1 is energized, and given it was energized via the set instruction, rather than a normal output enable instruction, it will remain energized until instructed otherwise. Note the TECO SG2 client programming software simulator utility indicates both instantiations of output Q1 are highlighted in green. This symbolizes that output Q1 is in the energized state. When the simulated field input device on input I3 is reopened, the make instruction examining input I3 no longer permits logical continuity onto the set instruction. However, output Q1 remains set in the energized condition as symbolized by the highlighted condition. The set instruction has thus allowed this system to maintain the last asserted state, as would a traditional hardwired holding contact without the time-consuming necessity of physically rewiring it or programming it yourself. When the simulated field input device on input I2 is opened, the break instruction examining input I2 permits logical continuity onto the reset instruction of Q1. Output Q1 is de-energized, and given it was de-energized via the reset instruction rather than normal output enable instruction, it will remain de-energized until instructed otherwise. When the simulated field input device on input 2 is reclosed, this system returns to the deactivated ready state with output Q1 de-energized. This simulation verifies the behavior of a simple holding circuit made possible by set and reset coils as implemented using the TECO SG2 client programming software. When the program is downloaded to a target device, note the subtle formatting differences between the programming software and that employed by the actual device. Note the set and reset commands are respectively upwards and downwards pointing arrows, and the break command examining input I2 and rung 2 is written in lowercase. Not all manufacturers use this particular shorthand notation. When the system is placed into operation, note that when an operator presses and releases the normally open green push button on input 3, the first pilot light turns on and stays on as we'd expect. When an operator presses and releases the normally closed red push button on input 2, the holding circuit is broken and the first pilot light turns off and stays off as we'd expect. Outwardly, the behavior of this program is identical to our two previous implementations, only the program is ever so slightly easier to read. Alright, that about wraps up this brief demonstration of holding circuits made possible using auxiliary relays, software-generated output instructions, and set-reset coils offered by the TECO SG2 PLR and the TECO SG2 client programming software. While we didn't unveil any startling new revelations, we did gain exposure to how one particular manufacturer implements these techniques and got an opportunity to practice programming and simulation, as well as observe the behavior of a latching program in operation. Remember to review these concepts as often as you need to really drive it home. Imagine how well lab will go if you know what you're doing. Thank you very much for your attention and interest, and we'll see you again during the next lecture of our series. Remember to tell your Lazy Lab partner about this resource, and be sure to check out the Big Bad Tech channel for additional resources and updates.